Hello all, welcome to my YouTube channel PowerBud. Today I am going to explain about the standard finished PCB thicknesses and layers. Before starting learning the PCB design, I recommend you to go through the PCB stackup or the PCB layer properties to understand more details about how they are going to fabricate the PCB. So here you can see we have n number of PCBs here arranged, and this is the top view of the PCBs, and here we have a cross-sectional view. So these PCBs have a cross-sectional view like this, and from this cross-sectional view we can understand that the PCB is a sandwich of some layers. That layer can be electrical, for example conductors, and it can be insulators. So here you can see the PCB stackup of a 6-layer PCB. You have 6 conductive layers, that is top, layer 2, layer 3, 4, 5 and 6, and you have some dielectric materials in between this copper material. And here also you can see the difference between the dielectric material. One is pre-pug and one is core, right? And one more is there, that is the solder mask. So what is a solder mask? Let's start with the solder mask. So you may have the confusion in PCB layer. You can see the solder mask opening, right? Some PCB Gerber you can see only it has solder mask. So you will think, okay, the solder mask color is green, but here it is when you're going to open it, and you can see the silver color. So you have to understand that solder mask is a negative layer. So solder mask is a negative layer means generally for the stencil you will create the paste mask, that is a positive layer, but the solder mask it is a negative layer. So what will happen, the layer which you define, for example solder mask opening layers, that they will remove. When they remove the solder mask, you can see this golden color or silver color pads outside the PCB. Means you can place some components and solder on top of the solder mask opening. So you have to understand it is solder mask opening. It's not actually solder mask. Solder mask is this colored enamel coating. It's colored coating over the PCB. That is the solder mask. And when you open the solder mask, you can see some copper area outside. That copper also plated with gold or any other type of material. So here you can see the layers: copper layer, pre-pug, core, and in between the copper layer you can see either pre-pug or core, or the combination of pre-pug and core. So let's check what is this. So this is again the cross-sectional view of a PCB. So on top of the PCB we will place the components, and this is this blue color one. In top and bottom you can see the solder mask, okay, and the solder mask opening area only this pins will place, there only you can solder. And here they have used a 2 ounce copper inner layer. That means there are some values for each thing. For example, the copper will be having specific thickness, the pre-pug will be having specific thickness, solder mask will be having specific thickness, and also the core will be having the specific thickness. So why different material, why we can't use only core or copper thickness, that I will explain now. Okay. So let's check what is the PCB finished board thickness. First of all, we have to check what is the overall thickness of the PCB. That will be the combination of multiple layers including the conductive and the dielectric layers. So PCB finished board thickness. A PCB is an assembly of one or more cores joined together by the sheet of partially cured epoxy called pre-pug. By stacking the combination of various core thicknesses and sheets of pre-pug, a wide variety of finished board thickness can be achieved. So you can now I will explain what is the difference between the pre-pug and core. The pre-pug is nothing but a dielectric material that is partially cured. That means it's like a wax or it's like a resin. When you melt it, it will become hardened. So that is the property of the pre-pug. So pre-pug is acting as a dielectric, as well as it will act as a adhesive between the core and the copper layer. And let's check what is the typical finished board thicknesses. So generally we will follow with the 1.6 mm thickness of the PCB, that is the standard thickness. But if you want some thin thickness based on your application, you can use any value below the 1.6. These are some standard values. and up to 12.7 you can create the PCB. That means if you have some heavy components or if your number of copper layers are increasing, for example 64 layer PCB and all, then you can go with the higher value of cross sectional thickness. Then coming to the core thickness. So cores are made up of substrate, that is fully cured laminate epoxy. Now I hope you understand the difference. So partially cured epoxy is called as the pre-peg and fully cured laminate epoxy is called as core. So core thickness also there. Then you can see here the different type of core thickness. Okay, so this core thickness is you have to select based on how strong your PCB is. Like if you want more strong PCB or if you want to adjust the impedance between the layers, then you have to select core based on this. But in general, if you don't know these values also, from fabricator point of view, they will definitely arrange this based on your application. For example, if you don't have any control over the impedance, like if you don't care about the impedance matching, in that case you can leave these values to the fabricator standard value. For example, if I am going to select a 1.6 mm PCB, then I have to only give this 1.6 mm PCB. Okay, then the fabricator will adjust the layers. For example, if I have a 6 layer PCB or 4 layer PCB, they will adjust the 4 layer copper. For example, 1 ounce copper, you have to mention that it's, for example, in your application you have a low current application, you need only 1 ounce, means you have to mention that only. The cross sectional area overall you can mention 1.6 mm. Then the fabricator will adjust the layer, for example the pre-peg and core layer, to reach the 1.6 mm in a proper insulation between the coppers. So that's a typical technique. If you don't know these values, like how to select these values, you can ignore for now. You can leave this to the fabricator. But this understanding is must before started designing the PCB. Then these are the standard pre-preg thicknesses. The pre-preg, as I said, it's a partially cured epoxy. The pre-preg is used to join plates, cores during the PCB stack come in sheets various of thicknesses. For example, when you want to use some kind of gum to, or for example, if you are going to use a thermosetting material between the PCB, then the bonding will be strong, and as I previously shown, it will come as a sheet. It is easy to place over the copper and core. Then it is easy to it is easy to use the connection between the layer. Generally what we will do, like generally the fabricator, what they will do, they will apply pressure and heat for creating this bond between the layers. So you can refer this also. These all are based on the IPC 222-1A standard. This is for your just a basic understanding I am explaining. And the copper thickness for PTH and wire. So wire also, it's very important because there is some standard wire plating thickness. So what is the wire plating thickness means? Generally once you finish the stacking up of the layer, the fabricator will start creating the holes in the PCB. So they will drill everywhere, like wherever you mentioned the wire or the plated through hole, those places they will start drilling. Then once they complete the drilling technique, what they will do, they will start applying this plating to the wire. So once the plating also, there are some values. For example, for thin plating 0.71 and for the average 0.79. Again, this is for class 1 and 2 type of PCB and class 3 PCB. These data are, more details are explained in the IPC 222-1A standard. So I recommend you to follow the IPC standards for the PCB creation. So here you can see it is like electroplating technique they are using to plate the wires and plated through hole walls. Then this is very important thing, the copper cladding foil thickness. So what do you mean by copper cladding? It is nothing but the copper thickness you are mentioning in the fabrication file. For example, if you want a PCB to handle 1 ampere maximum current, then you can go with something lesser than 1 ounce. So then you have to mention this, your PCB is 1 ounce. So 1 ounce is how many that you can see here. 1 ounce means 0.034 millimeter. Okay, this value table you can represent. For example, if you want to design a PC with higher current rating, then you can go with a 2 ounce copper, otherwise 3 ounce copper. So like that you can select. If you don't have that much current requirement, you can go with a lesser thickness also. This is the PCB layer thickness. Then solder mask tolerance. So solder mask, nothing, it's like a they will pour over the PCB. It's like a liquid, they will pour over the PCB. It's just like you can consider like a paint. It's a coating, they will pour over the PCB. For 1 like 0 to 5 mils thickness they will pour. So you don't need to mention this necessarily, because this value will change fabricator to fabricator, because they will have some standard process, or they will have some ink pen, like some standard values are there. So if you don't mention this also, that's fine, they will add this value, but you have to mention you need a solder mask opening, or solder mask, you need a solder mask. Okay, that's all from my side. I hope this video is useful for you. If you like the content, please like and subscribe my channel. Thank you for watching.